Hello everyone. So let's get into the next most important, most difficult topic among the students. No, even when I was studying, I tried my level best to understand, but unfortunately, I miserably failed. And even now, I find many students finding it difficult. But I think if somebody is trying to understand this topic from me, I can assure that you will not forget this concept throughout your life. And why you need this concept throughout your life is because this impulse is the form of message that is acting as a communication channel between us and our brain. I want to talk. What I want to talk, I'm trying to convey it to my brain in form of impulse. I want to write. This message I convey it to my brain in form of impulse. I want to dance. I want to sleep. I want to eat. I want to read. I want to drive. Any single action that I want to do, I am instructing my brain in form of impulse. So without this, we are all like a coma patient, right? We will not be able to do anything. So what happens in those comatized patient is that they are not in a position to generate their actions or generate this impulse. That is why they are not able to do any action. So we will try to understand what happens to a cell, how it generates impulse, and how it is trying to deliver it towards its entire length. That is very important, right? Now, how I teach my students is I try my level best to give them a concept of physics. Please make a note. This topic can be very well understood if you're strong in current electricity. You need not know every single details, but at least try to know Ohm's law and try to know what is a capacitor. Now, if you take a capacitor to have two parallel plates, it is going to store charges, right? Capacitor is something that stores charges. We try to see it in every single appliance. Now, what happens with capacitor? It stores charges as accepted. This storage of charges is going to be different when the appliance is in use and when the appliance is not in use. Now, if you take when the appliance is in use, what is going to happen? There is equal distribution of charges. There is equal distribution of charges such that the potential difference is going to be zero, right? When the device is not in use, the charges stored in the capacitor is going to be equally aligned along the plate. So if you remember, you will have a diagram something like this in your physics. So if you take the net potential difference is going to be zero because here 4 positive charges, 4 negative charges, potential difference across the plates are zero and also across the planes and the switch is also going to be zero. So when the potential difference is zero, obviously there is no flow of current, right? Now, when I switch on this appliance, right? When I switch on this appliance, what happens? This distribution of charges is going to change such that the flow of ion is going to begin. So when the switch is on, the potential difference is not zero. So when the potential difference is zero, or when the capacitor or the device is at the resting state, then no flow of current, no potential difference. So at resting state. But when the switch is on, when the potential difference is not in zero, it is going to be in the active state. So I have this idea. Just keep it aside. Just know potential difference, zero, resting state. There is some equal distribution of charges. When the switch is on, these charges are going to randomly just move out. It is randomly going to flow, thereby producing the effect. The same thing applies to vessel. Now, since we are dealing with neural control and coordination, let me try to explain by directly jumping into structure of a neuron. So say suppose this is my neuron, this is my axonal membrane, and this is my axoplasm. Now, when this neuron is in active state or when it is conducting the impulse, the charges are going to be randomly placed. So sodium ions, potassium ions, chloride ions. So all the charges, all the ions are going to be randomly placed. Okay, I'm just scribbling because just to make you understand that the charges are randomly distributed. I have no authority or I cannot quantify the charges when the neuron is active. But once a neuron has done its job, it has to be activated. What it does, how it is coming to an resting state. It is activated. Now it has to come to a resting state. How it is going to come? There are lots of mechanisms that makes or that renders this neuron inactive or to a resting state. Let us see what happens. Now, first thing is neuron. This is my neuron. And you all know I have got some ion channels on the neuronal membrane or on any cell membrane. You all know I've got lots of ion channels, sodium ion channels, potassium ion channel, calcium ion channel, chloride ion channel. So I've got ion channels for every single ion in every single cell membrane. Now, what will happen is one possible way what the cell does is it activates potassium channel. What it is going to do, say suppose this is my potassium channel, it activates my potassium channel. As a result of activation, what is going to happen? All my potassium ions are going to enter inside my neurons. Right? It is going to enter into my neuron. So this contributes to some extent. Okay, this does not contribute to majority, but it contributes to some extent. Second thing, here I've got neuron. Same, I have got channels. Now I'm going to concentrate on sodium channel. Say suppose this is my sodium channel. The other way is the neuron is going to block this sodium channel. Since it blocks sodium channel, what is the net result of blocking the sodium channel is the membrane becomes impermeable to sodium channel. So it is going to become impermeable to sodium ions, so the sodium ions cannot enter. So why this is very important is in a neuronal cell, the sodium ions are responsible for activating the neuron. That is for generating an action potential, for generating an impulse. Sodium ions are very important. So when I block the entry of sodium ions, I am trying to stabilize my neuronal membrane. That way I'm trying to reduce the action potential, trying to bring it to a resting state. So I can block the sodium channels. And at the same time, my axoplasm has got some negative ion proteins. Right? It has got some negative ion proteins. So during a normal active state, the negative ion proteins try to escape from the axoplasm. It tries to escape from the axoplasm to the outside environment. I try to block this too. So I block the protein exit. So all these are some changes that happen. So there are some minor contributions, but also it is very important, minor but important. So what are the things that happens is as a result of all this. So neuronal membrane, when it is at resting state or when it is approaching towards the resting state, at resting state or to attain resting state, it does all this. Okay, this it does even during no attaining the resting state. Also to maintain the resting state, it continuously does this because I told you sodium ions are responsible for causing action potential or activating the muscle. So I mean activating any cell, and I should constantly block that so that no single sodium ion enters into my cell. So at resting state or to attain resting state, my neuronal cell is highly permeable to potassium ions and impermeable to sodium ions as well as negatively charged proteins. So what happens here as a result of these three? Just understand, this is your NEET question. So the following are true with respect to a neuron in its inactive state. They ask you this. As a result of activation of potassium channel, just appreciate what happens there. Continuously potassium ion are entering inside. They are continuously entering inside. So the concentration of potassium ion is more in axoplasm. There is blockade of sodium channels. So there is no sodium ion entry inside my axoplasm. So I can write this in two ways. Sodium less in axoplasm or more in extracellular fluid. It is more at the source, less at the sink. And there is blockade of protein channels, so the negatively charged proteins are not able to enter into my extracellular fluid, so it accumulates in the axoplasm. So there is increased proteins in my axoplasm. So in short, if I try to define this in terms of axoplasm, more potassium, less sodium, more proteins in the axoplasm. So all these three contribute to resting state. Now, the most important villain here is one thing. It is called as sodium potassium ATPase pump. So what I will do here for you is I will draw a big neuronal cell, and on one side, let me show you sodium channel. Let me show you a potassium channel. Let me show you a protein channel which carries proteins. And I'm going to show you something very special. That is, let me draw it in a simplified form. Say suppose this is my sodium potassium ATPase pump. So what I am going to scribble here are all the factors that is responsible for giving a neuron a polarized state or a resting state. So let me name this. This is my sodium channel. This is my potassium channel. This is my protein carrier. And this is my sodium potassium ATPase pump. The name is not given in the textbook, but whatever I'm going to discuss or whatever is being discussed in NCERT is about the sodium potassium ATPase pump. Now, what I told, this sodium channel is blocked. Potassium channel activated. So there is entry of potassium ions. So potassium channel is activated. So more potassium ions. The protein carrier is blocked. Henceforth, increased proteins. It has less sodium ions. Now, what this sodium potassium ATPase pump does, the final but the very important step is it can allow movement of both the ions, sodium, potassium, right? So it allows both the ions to pass through. So what happens is already this axoplasm contains only few sodium ions, right? All those sodium ions are going to pump out via the sodium potassium ATPase pump, and your potassium will enter into the cell. So what does this sodium potassium ATPase pump does? It allows the exit of sodium. Sodium, I don't want you. Please go out of my life. Neuron is sending it. So it is sending it out. So from the axoplasm, sodium ions are entering outside. This ECF is getting angry. That is, the extracellular fluid is getting angry, and in turn, it is trying to take revenge. It's like typical hero villain story, right? Villain will give only two punch, but hero will give three punch, and the villain will die. Right? This is what a typical Tamil movie does. Same thing. The extracellular fluid here is your villain. So what he does? villain, and imagine neuron is your hero, ECF, that is your axoplasm is your hero, and extracellular fluid is your villain. Villain, he hits the hero twice. So in what way? He is giving two potassium ions inside. Just start with this. Okay, potassium, villain, ECF is giving two potassium ions inside. But our hero is very strong. Who's our hero? Sodium. Because he is one who is going to activate the neuron, right? Depolarization. So this hero, what he is doing, you are hitting me twice, I'll hit you thrice and I'll make you die. And he's sending three sodium ions outside. So if you take, just compare all the factors, there is an extra positive charge. So here if you take some potassium ions are entering, here already there are sodium ions that are present outside because it is not getting inside. Negative proteins are also not going outside. So if you take already the positivity charge is dominating in the extracellular fluid. Now the sodium potassium ATPase pump, what it does, it is sending one positive charge extra every time. Two potassium, it is coming inside, but three sodium is going outside. So again, one positive charge is more there. So as a result of all these, blocking of sodium ions or the membrane becoming impermeable to sodium, membrane becoming more permeable to potassium, membrane becoming impermeable to proteins, and exit of three sodium ions for entry of two potassium ions. In the typical resting state, the neuron becomes positive outside and negative inside. Okay, it becomes positive outside and negative inside. So a neuron in a resting state will have positive charge outside and a negative charge inside. This is the story of a membrane attaining a resting state. Now, when I measure this resting state, now let us get back to the capacitor itself. When I get back to the capacitor, I told you the net potential difference is zero. I did not talk about the potential being zero. I hope you want a difference between potential and the potential difference. When I take 2 points, say suppose point A, point B, I try to measure the potential difference, that is the quantity of the charge. The difference is zero. That's why I say V here denotes potential difference. So at A 60 volts, at B also 60 volts. So the net potential difference is zero. There is no movement of charges. So if you take a capacitor, he will give you the specification like 40 watts, 60 watts. It has got 120 volts, 220 volts. So you will have capacitor saying 220 volts, 120 watts, something like this. I do not know the exact specification, but you have something like this, right? So which means what? He's talking about the potential, which means at resting state, if you try to measure the quantity of the charges present, yes, it is 220 volts. But when the device is off, the external source, right, the main board and you are going to be at the same potential. So the net potential difference is zero. The same thing is going to happen here at the resting state. So we have seen what are the factors that is contributing for a resting state, right? If I try to measure this portion by using some device, the potential I record is called as resting membrane potential, RMP, resting membrane potential. So the potential of the neuron at the resting state is called as resting membrane potential. Now, when I try to change this resting membrane potential, then I say that the neuron is going to be activated. It can either be a positive activation or a negative activation, but there is some change. So we'll see what happens. Now, a neuron is at resting membrane potential if there is entry of sodium ions continuously. There is entry of sodium ions. Then it is going to be a stimulating factor. I call such stimulation as action potential, or I call it as depolarization. So when I say depolarization, so already in the resting state, the neuron is at a polarized state. I'm trying to depolarize it, which means what I'm trying to remove that polarizing factor. So I try to give lots of sodium ions inside. So it is going to activate the muscle or depolarize the muscle or the neuron or whatever structure concerned. That is called depolarization. So as a result of depolarization, what will happen is this RMP is going to increase. Say suppose RMP of a cell is going to be 70 volts. As a result of depolarization, slowly the potential of the neuron is going to increase to 200 volts. This is because of what? Depolarization, which in turn is because of sodium ions. Now, when I try to now, once it is at 200 volts, I should try to decrease it, right? And that process of decrease is called as repolarization. So this repolarization is due to potassium ions. So there will be stoppage of entry of sodium ions and entry of potassium ions. We have already seen what happens, how a neuron will enter into a resting state, right? The same process will happen. So it's mainly because of potassium ions. So this is about depolarization or repolarization. So the conduction or the change in the resting membrane potential that happens due to flow of a particular ion is called as action potential. Can be either depolarization or repolarization. But there is some flow of ions that changes the resting membrane potential. I call it action potential. Right. So this is what I want you guys to understand. Generation of impulse is very simple. You will just simply give you the reverse of the current and all that. I hope you will be able to understand. In short, if you want me to say, I'll just derive the neuron into two aspects. This part is in resting state, which means what? Outside is positive, inside is negative. Now, I am trying to bring in a potential here. So what will happen? All your sodium ions will enter. Right? All your sodium ions will enter. So what will happen as a result of entry of continuous positive ions inside? I told you sodium ions are more in extracellular fluid. ERO is more in extracellular fluid. So he's slowly entering towards the villain zone. So what will happen? This outside zone will become negative and inside will become positive because it is loaded with sodium ions. Now, this part of the membrane is depolarized and this part is at resting stage. Now what will happen is the sodium ions that entered will try to move to the next piece of neuron. Try to move towards the next piece of neuron. So imagine that this line is myelin sheath. So I told you conduction is going to be jumping conduction or saltatory conduction, right? So it crosses the myelin sheath and it directly jumps to the next piece of node of Ranvier. So all the sodium ions are going to continuously travel to the next piece of node. So what will happen gradually? All these positive ions are trying to get here. Now, in order to complete this loop, what will happen is, because the current loop has to be complete, right? You know the physics, reverse flow, right? So this loop has to be completed now. For completion of this loop, this positive charges will try to move here. Able to understand? This is what you need to know. Physics, current, electricity, completion of the loop. Because only one side, it is impractical to say that current is flowing on one side. Right, it has to move to the other side also. There is always a concept called completion of loop. So when sodium ions positives move continuously from here, in order to counterbalance the effect, the positive ions outside will start moving from this side to this side. So what is going to happen is, just observe, first piece is going to be like this because this has lost sodium ions inside, right? This has lost sodium ions here, so it will become negative, and this has gained positive charge from the next piece of neuron here, so it will become positive. Whereas the other side, if you take, is going to be like this. This is how impulse is generated. So saltatory conduction, and you just have to explain this current loop. This is very important, right? So this is what I want to actually convey. I hope you got it. If there are any doubts, post in the comment section. I'll try to clarify. Thank you all. Tata, bye.